Okay, another tension question was when you have a sign, in this case, 7 kilogram sign, attached by these two cables, cable 1 and cable 2. Draw a force diagram. We want to find the tensions in the sign. So draw a force diagram, dot, you got the weight down, use a W or an FG. Remember that the weight is mass times G. 7 times 9.8 is 68.6. Newtons. This cable, cable 2, goes off at 36 degrees to the horizontal. That's 36 degrees. That's T2. And then this cable's pulling to the right. And that is T1. Notice I use solid arrows for the real forces and dashed arrows for the components. I just find that helpful. So this is T2y, and that's T2x. Why do I have to make this into a triangle? Because T2 is not straight up, or straight down, or straight to the right, or straight to the left. And so it needs a triangle because it's a little bit to the right and a little bit up. Okay? By the way, I didn't draw this very well. These two match because the system's in equilibrium. The sign is at rest. Okay, so to solve this, I'm going to start in the y-axis. Why? Because I know this piece of information in the y-axis, the weight. So in the y-axis, the net force in the y-axis is equal to 0. Therefore, T2y equals the weight, which is 68.6 newtons. So this is 68.6. And once you know that and the angle, you can find the hypotenuse, and you could also find T2x. So to find the hypotenuse, T2, which is something I need to find, use the sine. So the sine of 36 degrees, I'm using sine because that's opposite, is opposite over hypotenuse. So that's T2y all over T2. Solve for T2, and that equals T2y, which is 68.6. 68.6, that's the value of T2y, divided by the sine of 36 degrees. All I did was rearrange this trigonometric equation to solve for the hypotenuse. And when you solve for that, it comes out to be, what did I get? 117 newtons. 117 newtons. In the x-axis, the net force in the x-axis is equal to 0. And there are two forces in the x-axis. I need to find one of them, T1. How am I going to find T1? Well, it's being balanced by T2x, which is the other side of this right triangle. So if I find that, I will have found the value of that. That's the goal. So T1 is balanced by T2x. So let me go off to the side and find T2x. Now that you know an awful lot of information here, you know the hypotenuse is 117, you know the opposite side is 68.6. I can use cosine, tangent, Pythagorean theorem, whichever one. They should all work. I'm going to use tangent just because I want to. So the tangent of this angle is opposite over adjacent. Opposite over adjacent. I need to solve for T2x. So multiply both sides by T2x to get it out of the denominator and over here, and divide through by the tangent of 36. You see T2y has a value of what? 68.6. Divided by the tangent of 36 degrees. And that comes out to be 161 newtons. So this is 161 newtons. So I have now solved the problem. The tension in cable 1 is 161 newtons. The tension in cable 2 is 117 newtons. Done.